Hello, my name is Matthew Randall, and I am a student at the University of Texas at San Antonio. Today, I will be showing you how to perform column chromatography and thin layer chromatography. Begin by securing the funnel to the top of your column. Next, add 12 grams of pre-weighed alumina to the column through the funnel. Tap the column to make sure that the alumina lies flat. Next, we will add 1 centimeter of sand to the top of the alumina. Make sure you have an Erlenmeyer flask beneath the column, and then slowly pour 25 ml of petroleum ether. Petroleum ether is used to wash the walls of the column. Open the stopcock to drain the petroleum ether. Stop draining once the petroleum ether reaches the top of the sand so that the sand does not dry out. Add 0.5 ml of petroleum ether and 7 to 10 drops of dichloromethane to dissolve your sample. Have your TA assist you with this process. Using a Pasteur pipette, load your sample to the column. Add a new Erlenmeyer flask beneath the column and open the stopcock to drain your sample to the top of the alumina. Proceed by adding 35 ml of fresh petroleum ether to your column. Open the stopcock and collect 10 to 12 fractions of 5 milliliters each. Make sure that your tubes are labeled. 5 ml is approximately half of the volume of each tube. Once the petroleum ether has eluted to the top of the sand, add 20 ml of dichloromethane to the column. Open the stopcock and finish collecting your next fractions. Once you have collected your 12 fractions, you can proceed to the thin layer chromatography. Grab a capillary tube and dip it into fraction 1. You will see that the liquid makes its way up the tube. Spot fraction 1 on your TLC plate. Dip it for just a second and switch to a new capillary. Continue by spotting the rest of your fractions onto the TLC. Add the TLC plate to the developing chamber. Pour 10 ml of 15% DCM in petroleum ether into the chamber. Add the plate and lean it against the back wall of the chamber. Add the lid. Watch as the DCM rises up the plate. Before the solvent reaches a centimeter from the opposite edge of the plate, remove it from the chamber and mark with a pencil how far it traveled. Take the plate to the UV light. Under the UV light, Use your pencil to circle the spots to visualize how far up the TLC plate they traveled. Circle each spot. The purpose of the sand is to stabilize the alumina and to absorb shock from pouring in the solvent. The mixture of fluorine and 9-fluorinone will be caught in the alumina until the mobile phase solvents are added. The less polar molecule, fluorine, elutes first because it has a higher affinity toward the nonpolar mobile phase. 9-fluorinone will remain on the polar stationary phase of the alumina, and a more polar mobile phase is necessary to elute it. Because 9-fluorinone is more polar than fluorine, the nonpolar mobile phase has less of an effect on its elution. As the mobile phase travels through the column, the molecule with a greater affinity for the mobile phase will elute first. Without the addition of sand, the alumina can shift as the column is adjusted and the solvent is poured. This will lead to an uneven starting point for the molecules, and the procedure will be compromised. Do your best to make sure the alumina stays level. Shifted alumina will skewer your results. This snapshot of the column shows how an impure fraction is developing. There is a mixture of fluorine and 9-fluorinone. The shift in the alumina caused this, so make sure your alumina and sand are level. Another problem to avoid is a dried out column. If the column dries, it will crack, and the gaps will cause the molecules to run through the column in an undesirable fashion. Do not let the column dry. Once you've spotted your fractions onto the TLC plate, move the developing chamber to the UV lamp. You will need to quickly place your plate under the lamp and circle your fraction spots. Use a ruler to measure the distance that the solvent and the fractions have traveled. For each fraction, calculate the retention factor RF using this formula. RF equals distance the molecule traveled divided by distance the solvent traveled. Repeat the calculation for all fractions seen under the UV lamp. Now you've seen how to perform column chromatography and thin layer chromatography. Thank you for watching.